So today we have a Rotel 240, come from the same dealer as the Harvard base station, and he's turned it back from an illegal modified 80 channel set into one which can be used legally. And again, this is one that he's got stuck with, so probably the same thing. We may have to dig our own demonstration one out and see where the wiring has got butchered. I think we'll open it up first. We'll probably have to take the bottom off as well, but we'll start with the top. I'll put the soldering iron on because chances are we're going to need it. So the lid's not connected, so that's fine. So have a quick look for seeing if anything is obviously distressed. So I think we'll take the bottom off at this point. We can't see anything on this. This doesn't look like it's been 80 channels, so I probably read the wrong email. Alright, we'll get it plugged into the test gear. So I think we'll just start off by jotting down what's left of the serial number. .07240. So with the standard replacement light, get it powered up, power on. Okay, so PA, testing 1 2, testing 1 2, so that's working. Back to CB. No audio. It's transmitting, it's about on frequency, and it's not receiving, so we'll put 2779125 on the signal generator. Quite a massive signal there, it's 100 microvolts. We'll drop the signal generator. I have got squelch operation. Let's put the that's working. So it's like volume control has no effect. put the signal back on. Oh, it does. I don't think he's deaf because we can. That's 3 microvolts. It's just we can't hear it. Just check the detector for a start. So let's put this at the picture-in-picture on. We'll go over to the oscilloscope for a start. Just having no effect. It starts to make you wonder if because there's no difference, it starts to make you wonder if the detector it makes you wonder if the coil's open circuit. Well, you know, that's something which can be done relatively easily. If only I knew where the solder sucker was. There it is. One or two potential dry joints along here as well. Good. Right, so that's got that one out. Now that's our scrap one. This is the very, very tired with the knackered PA. So, yes, I think that's probably got rid of the dry joints. Power it on. Okay, we'll have a look at some capacitors. Not many parts in the detector. This is the aftermarket circuit. It's not always accurate. So we're looking at this area here, and this is the detector coil. So I've changed the IC behind the scenes. We've already changed that capacitor. There it is, and there we are, blown up. Not a lot there, folks. So what was that capacitor I changed? 82 possibly? So I'll just check. Yes, capacitor 82. Starts to make you wonder if something's been altered. Well, I've come up against a clue. Just zoom in a bit. Especially if we find the right camera. So, the signal comes out of pin 12, goes through capacitor 87, resistor 48, and then disappears off. If we look round here with our golden finger, I can hear plenty of gain from the transistors that follow here. So I'm just looking, we've got solder on that resistor, which is what, 19k, 18k, and you think, why would that be? And I think this has had some kind of processor in, like an FM noise crunch or something like that. It's been, I think the phrase is farted about with. So if we look for a resistor 48, 100k, it's here. If we look for a resistor for capacitor 87, it goes across there. There's nothing fitted. Let's look at our scrap set. We've got 100k, and we've got capacitor 87. So, if capacitor 87 is missing, I'm not looking on the back, but if it's missing, there's actually no feed path whatsoever. There's capacitor 87. So, tell you what, let's whip it off this scrap chassis. I like to keep costs down when it's this gentleman. But again, without, no, there's no capacitor. There's no totally open circuit audio path. But without, that's something to compare with. Once again, I mean, this is why he's struggling, because it's not the tune-ups, it's when they've been messed with. So it's Sunday afternoon, Mark's gone home. Let's put the power back on. Absolutely normal. There we go. So I'll put the oscilloscope back on. I know this is not the way we do them. We don't do receive first. Pop that back on picture in picture. Turn the volume down. Just do detector. False lock point. Not that one. The upper one. Right. Mind you, we've got some bars out on this display, or a bar out, so, and it's a dry joint. When I flex the board, it comes and goes. But we'll go through the tune-up, and we'll start with the VCO. Good. Do the transmitter, and I'll take a tea break. Resistor 4 should be 4 volts in transmit and receive. We haven't actually got transmit. Why is that then? We're on low power and it must be not set. Whilst I'm at that, I'll put some service oil on the preset, and that can be soaking in. So 3.7 on transmit, so we'll just do this. This is the person who retyped the RVC240 notes for me, which has been very much appreciated. Wow, that's tight. I may not bother if it's too tight. And in transmit, we'll just do that with the trimmer. Trimmer that's unfortunately got wax in, which is not somewhere where you want the wax to ever go in. I'm going to come back to that. I'll just go through the tune-up. So make sure we're on the main camera. Go to channel 20. That's spot on 4 watts, isn't it? So a little peak there. Peak there. Peak there. Before I do the PA, because it's spot on 4 watts, I'll just check, because he's probably done this. It's 4 watts on channel 40, it's 4 watts on channel 1, so he's already done that. So I don't need to peak that and then drop it, because he's done it. So that was very slightly out, but you know, that's just one of those things. It's neither here nor there. He's always very thorough on these, but I can't expect him to notice that missing. I like that one to be central. Check the deviation. 1 to Arlo. Why aren't we doing anything? Because we're on channel 1. We're on channel 40. Wallow, 1212, Wallow. We'll check this with the test set behind me. It's a little bit high, that. Wallow. There we go. Low power, just sort that out. See where we are with the frequency. I've no doubt it's spot on. Well, it's 107. I mean, that's neither here nor there either. We'll just pull that up for this test set. But to get to that conclusion, I had to change the IC in the coil. You see, this is, you know, it may only be a 6p capacitor, but I've used some second-hand parts, and that's the way out of it for him. So meter on transmit. Can't see a thing. I'll put the other glasses on. We're on low power, aren't we? Banging across that. That's that. And we've done deviation, we've done transmit 1. Let's move to the receive. I still want that cup of tea. So let's go to the cyanide meter. One day I'll move the I might have reset it. Okay, let's see what we've got. So I've put that right because obviously I fiddled with it, and we've got 0.67 microvolts, which is fine, but this can sometimes do better. 0.58 and Oh, it's 1 dead. Squelch. Maximum is 1.5 millivolts. And threshold is 3.2 microvolts, which isn't good enough. 3.2, isn't it? S meter, that's 100 microvolts. It's, well, it's beyond. Okay. So it wants a good going through, but of course he won't have been able to touch the receive until it was fixed. So this one usually makes a difference. Make sure we're on the right one. A bit more signal for these. Wired on the detector. Make sure it's in the right place. We've now got 0.46. .4 and 0.85. So put 100 microvolts on the signal generator. We'll set the S meter. Just like that. And let's deal with this squelch. So keep that at 100 microvolts. Put the squelch to full. Turn the preset till the signal comes in. About there. That's now 100 microvolts. The threshold. Let's see where it is at the sensitivity. And set the squelch. No, that's not right. It's just as bad. So I just wonder, we're going to have to go backwards. We're going to have to see whether this detector's right again. So 100 microvolts. So it looks right there. Yeah, it is right. But you know, folks, it isn't right. Just look at this coil. Go back to squelch. No, it's 3 microvolts for squelch. Let's try again. It's 1.2 microvolts. It's not good, not as snappy as they usually are. But careful adjustment and readjustment. It's usually around 1. Good. I'll look for dry joints, have a cup of tea, and see whether we can get that channel display right. Right, well I reckon that's it. So we'll put the lid back on. Good. Time to turn the test gear off then. Unplug that. I'll put a couple of screws in for now. And just plug it into the aerial and draw the video to a close. So, you know, I'm not surprised he couldn't find that. And it's alright doing 40-minute videos, but it took me a lot longer than that in real time. She's studying those circuit diagrams and trying to work out what's happened. So hopefully we'll get an on-the-air test done on this today. So this one wasn't an 80 channel conversion by the look of it. It was something else has happened to it, and I suspect some kind of FM noise cruncher. Oh, we're running out of screws. Yes. One of them is a slightly different type, so I'll just put one of our new ones in. So we haven't got a slightly different head. So I'm going to monitor the VCO, but I'm going to leave this on overnight, because remember there's wax in the transmit one. It's not something I like to see. So I'm going to leave it on. I'm not going to leave it off overnight, switch it on in the morning, and as long as it works locked on channel 1 and 40, well, we can leave it, and if it doesn't, well, it's time to change that trimmer capacitor. But I'll try and keep the cost down. Still transmitting fine. Try it on channel 1 and channel 40. Yep. One Anna Roger. Well, I think they're all having their tea. Right, we're getting on the air test done. Thank you for watching. Rotel 240 Cybernet 134 chassis from 1981.